we have two talks in this afternoon session. The first one will be a 45-minute spot, so that will translate to roughly 37 minutes and 33 seconds for talk, and the remainder for questions. So I'd like to introduce Greg Wilson. Greg Wilson is the creator of Software Carpentry, a crash course in computing skills for scientists and engineers. He has worked for 25 years in high-performance computing, data visualization, computer security, and academia, and is the author or editor of several books on computing, including the 2008 Jolt Award winner, Beautiful Code, and 2 books for children. Greg received a PhD in computer science from the University of Edinburgh in 1993 and presently runs the Software Carpentry project for the Mozilla Foundation. So let's welcome Greg for his talk about software carpentry and the lessons learned.
Okay. Thank you. So there are the boring details. What you really want to do is hop on that Etherpad. That's what the Etherpad looks like. Please come join, take notes, ask questions, collaborate. So here's what we're going to do. We're going to recap a series of conversations I've had, and I'm going to do both voices because I have a little kid. I've had a lot of practice doing funny voices, and also singing the chorus of the song from Frozen over and over and over and over. So, 1997. Hi, I'm a programmer. I'm starting a web company. What do? Oh, I'm a designer. I know how to select and arrange text and images in ways that are appealing, informative, and usable. Huh, that seems pretty simple to me. I mean, I know how to use a font selection dialog. I don't think I need to hire you. A few years later, bumped into the designer. So how'd your startup go? Yeah, it tanked. People said that my site was ugly and confusing. I guess I've learned my lesson. 2014. Hi, I'm starting an online education company. What do? Oh, I'm a teacher. I know how to select and arrange learning materials in ways that are appealing, informative, and effective. Huh, that seems pretty simple to me. I don't need to hire you. Welcome to my life. Here we go. I run a project called Software Carpentry. We are lab skills for scientific computing. This project started because I was working with physicists and astronomers using first-generation and parallel computers, and they would come into my office with their 50,000 lines of Fortran and ask me to make it a zillion times faster, and they had never heard of version control and weren't really sure why they should be writing functions, because nobody had ever taught them. And it is unfair to look down on people who aren't doing things right if you've never shown them how. I did anyway. It's difficult to look down on physicists, but I managed. But I realized by the mid-1990s that I was doing more harm than good. If you give a supercomputer to the average scientist, it is rather like giving a Ferrari to the average 16-year-old. And the crash rates are similar. So starting in the late 90s, we began running classes to teach them all that stuff that is boring but works. Version control, shell scripting, how to modularize a program, how to manage data. Right? We don't have enough data yet to publish, but the feedback we get is that a 2-day workshop will save most scientists a day a week for the rest of their careers. Note to any faculty members in the audience, this does not mean they will finish the degree earlier. They will still go to end of funding plus 10%. But they'll get more done and they'll publish more and they can tackle problems they could not tackle before. We teach the Unix shell, Git and GitHub, Python or R, and SQL. But what we're really teaching is task automation, how to track and share your work, how to modularize your code, how to turn it into functions that are readable, testable, and reusable, and that those are in fact all the same thing. We teach them SQL, but what we're really teaching them is what structured data is. What's a key? What's a null? Why do I care? So it's bait and switch. We advertise the things on the left because they've heard of those and will show up. We teach them the things on the right. Last year, 103 instructors, 97 2-day events in 12 different countries, about 3,500 people went through. We're going to increase all of those numbers by about 50% this year. So we're not huge, but we're not small, and we're growing. That's where we've been. And you can't see the numbers in the yellows, but we're everywhere, and if you want to help, give me a shout. But that's not what I'm here to talk about today. Nor am I here to talk about all of the volunteers who make this possible. Our instructors are volunteers. Okay? The host for the workshop pays their travel and accommodation, but they volunteer their time, partly to make the world a better place, partly because it's more fun to work with people who know these things, and partly because it's a real boost to their careers. The academic job market is pretty tight right now. So if Trevor, raise your hand, Trevor, who's one of our instructors, wants to get a job at MIT, going down and teaching a workshop in Boston and showing people just how useful he is, gets his resume out of the big stack and into the short stack right away. So, first thing I've learned, most scientists think of programming as a tax they have to pay in order to do science. This idea that we're going to teach everybody programming and that they're all going to want to learn is wrong, and we just need to get past that. How many of you do home renos? How many of you enjoy doing home renos? Yeah, Chris Attlee puts up his hand. This is a guy who enjoys refactoring makefiles. Like, we're talking about way out on the bell curve. For most of us, hanging drywall is something we have to get done, not something that we really look forward to. Similarly, if you take the average chemist, she could have chosen to go into computer science. She chose to do chemistry. That's what she wants to do. Programming is something she has to do along the way, in the same way that statistics is something that she has to do along the way. So if we say, wow, this is really exciting, let me talk about recursion, we're not helping her. Okay? Thing number 2, and this one took me a long time. The curriculum is full. Every time we want to add something at any level, we have to identify something to take out. And right now, I use this as an acid test. If you tell me we should have more programming in schools, my very first question is, what will you remove to make room? If you're not willing to do that, I'm not interested in talking to you because you're not being honest. Yes, I absolutely believe we should be teaching programming in high schools. Do we give them less gym so they're more obese? Do we teach them less about French or English, depending on which part of Canada you're in? How about we teach them less math, right? How about we give them less music? Every time you want to add something, you've got to take something out. And if you want to do it as evening or weekend, then you're cutting into all the things that they currently do at that time. And if you want to put more computing into the undergrad program in mechanical engineering, you have to convince a prof that it is more important to a mechanical engineer's education than thermodynamics. Okay? If you're willing to do that, then you're being honest about the challenges we face. And this has been a real struggle for me, and this is why we run these 2-day workshops outside the normal system. Our goal is to reach graduate students and then wait 15 years so that they will rise up through the ranks till they're sitting on the curriculum committee, and then they can decide what to take out to make room for this stuff. This is how statistics became part of education in the life sciences and medicine. The generation that had to learn it during the Second World War, particularly in the UK under Norman Fisher, 15 and 20 years later, when they were on the curriculum committees at Oxford and Harvard and Cambridge and UC London, they said, right, we're going to take this out, and this was different in every school, so that people have to learn stats. You've got to play a long game. I hate that idea. I am not by nature a patient man, but this is how it works. Wolfgang Pauli's line, science advances one funeral at a time. Okay. But all of this stuff is in the paper. Go read the paper. It's short, I think it's well written, and it's open access. So let me tell you something useful. Okay, let me tell you some things that aren't really in the paper. Victory comes from the accumulation of small advantages. If you want your workshops to work, if you want your teaching to work, there is no single slam dunk. There are a lot of things that can go badly wrong, but in terms of what you do right, it's a collection of small things. How many of you do live coding when you're teaching? Okay, no slides. You plug in, you start typing. Do you know why it's better? Reason number 1. They see you screw up. Why is that better? They can see how to diagnose and recover from mistakes. It's called lateral knowledge transfer. They see what to do when it goes wrong, because that's never in the textbook and that's never on your slides. Right? They also get the reassurance of knowing that, hey, if the teacher's going to screw up, it's okay for me to screw up. You're giving them permission. Etherpad. We always run an Etherpad when we're teaching. There are students who will not raise their hand for whatever reason to ask a question, but they'll ask it on an Etherpad. It gives them a shared note-taking area. It gives you a way to share snippets of code. Etherpad or something like it is the best teaching tool I have found in years, except for one other. How many of you teach with sticky notes? Okay, the next time you teach, go and get 2 pads of sticky notes, 1 red, 1 green. Everybody gets 2 sticky notes. When things are going well, you have a green sticky note on your laptop. When you need help, you put up a red sticky note. People who will not ask for help when they have to do this can just very discreetly say, as if they were bidding at a high-priced auction. From the front of the room, you can immediately see who's finished and who needs help and redirect people. It pulls people out of the shells, it's cheap, it works incredibly well. It's the poor man's clicker. Okay? Do this and you'll never go back. We are teaching workshops here on Monday and Tuesday. Hands up if you're actually going to be teaching one of those or helping with one of those. I know we've got a few people in the room. Okay, we are going to be handing out sticky notes, and most of the people who attend those workshops will then use them when they teach. All right? It's a wonderful little technique. Minute cards. Is Tracy here? I'm looking straight into a bright light. Tracy Teal in the back introduced me to this. So you've been teaching and they've been doing sticky notes to ask for help, let you know their status, yes or no, we're ready to go on, however you use them. Coffee break comes around, everybody takes the red sticky note and very quickly jots down one thing they didn't get, one thing they didn't understand. And on the green thing, one thing they learned. And they put them on the table on their way out of the room to grab coffee. In a room of 40 people, it takes you about 2 minutes to go through those, so that when they come back from coffee, you know which part of the lesson you need to repeat. They won't come up and say, I didn't understand X. And if they do, it's 1 out of 40. You don't know if that's representative. But if they do that on the way out and they come back and you say, let's just go over call stacks one more time, they will thank you for it. And you'll never go back to the old way of teaching. Signing up with friends. We discovered this by accident, and then I discovered that people doing educational psychology research have known this for about 55 years. Watch what I do with my hand. So, our workshops used to have the same crappy gender ratio that you see in a computer science undergrad class, 12 to 15% female. By accident, sort of, we ran a workshop in London where people were supposed to sign up in groups. Don't sign up as an individual, round up a few lab mates or friends and come as a group. Gender parity. Why? Anybody want to guess?
I wouldn't be guessing.
You know the answer. Anybody? In the back there.
Less scared.
Less scared because you know that you're with people you trust. Even if they're not also from the underrepresented group, you know, somebody's got your back, there's somebody you can turn to for help. You're not going to be the dumbest person in the room, because come on, this is your lab mate. You know they're as stupid as you are. No. So the work on this was done in the early 1950s, trying to get recent immigrants, particularly Jewish kids in New York, to sign up for sports activities in neighborhoods. Even if they're not signing up with other Jewish kids, the fact that they know those people and trust them makes the at-risk underrepresented groups more likely to show up. And I hypothesize, but cannot prove, that one of the reasons we've slowed down our teaching over the last 2 years is that we're actually finally reaching the people who need our help most. Because the underrepresented group in our workshops used to be the people who really didn't know how to program. And they were afraid to come out to a programming workshop because nobody wants to be the dumbest in the room. But now they're showing up with other people who are just as backward. They're there. Okay? So do group sign up. I promise you it will increase diversity on several axes. Editors are hard. Things that we take for granted are really hard for them. And the biggest mistake we make is to use the word just. How many of you use the word just when you're teaching? Really? Please stop. Right? It's the passive dismissive adjective. Oh yes, you just install a virtual machine and then you just install Ubuntu on top of that. Oh, just make sure it's the right version of Ubuntu, and then you just synchronize the network card so you can just transfer data. And they're like, what? Getting editors to run, getting them to understand a text editor, which is different from something like Word, and how to save files in the right directory so they can find them to run them, is hard, because it is intrinsically hard. It's just we've been bitten by this so often that we've got so much scar tissue, we can't feel the teeth anymore. We've forgotten that there was something there to learn. And this is part of what we do with our instructor training, is try to remind people that there is something there that needs to be learned. Oh yeah, one other note, if you're organizing a workshop, make sure the washrooms are unlocked. because, okay, the rest of that story tells itself, right? The other part of that story is make sure that campus security knows you're supposed to be in the room. And you can fill in the rest of that brief but exciting story as well. Here's lesson 4. And if I could send a tweet back in time, 5 years or 10 years, and tell myself something, this is what I would tell myself. As a species, we actually know a great deal about how people learn and how to teach them. There is as much evidence-based research in education as there is in medicine. The difference is you're probably more aware of the research in medicine than you are of the research in education. If you're going to do one thing after this talk, go and grab a copy of that book and read it. The Learning Sciences group at Carnegie Mellon put this together. This is a summary as of 2010 for non-specialists who are willing to read dense text of what we know about cognitive psychology, educational psychology, instructional design, social forces shaping learning. This is the everything we've got boiled down into one book. It is not an exciting read. And I'll come back to that. It isn't an exciting read, but it's a really useful one. How many of you have kids, please? Yes, and the kids in the back put up their hand. Excellent work. I really like knowing enough about education to fact-check my daughter's teachers in the same way that I like knowing enough about medicine to fact-check my sister's oncologist when she was sick. How many of you are in a startup? Do you like knowing enough about tax law, business legislation, intellectual property that you don't have to take the lawyer's word for it? You don't have to be an expert, but come on, 250 pages? That's a good investment of time. So, footnote to this lesson is most programmers and most people in business and most people in government, even the ones that are really excited about teaching, don't know that this knowledge exists. Right? There's a lot of social forces around that. We can go into it in the question period. But the ultimate answer is that a week of hard work can sometimes save you an hour of thought. Most programmers would rather spend a week or a month hacking on a new MOOC website than an hour reading research papers to discover that the pedagogy embedded in their website is actually useless. I'm not mentioning any MOOC platforms by name, Khan Academy, but what too many people are doing is taking bad teaching and accelerating it by putting it on the web, rather than finding out what good teaching is and then accelerating that. Okay. Let me give you some examples. And these slides will all be up. I'm sorry for the long URL, but I'll come back to this, and I'll actually paste it into the Etherpad. Really good slideshow from a few months ago from John Hattie in New Zealand. What he does is collect studies in education and do the meta-studies on top of that. So his database has almost 100,000 studies from the last half century on various teaching and learning techniques. And what he does is look at what is called effect size. Okay? Basically, what fraction of a standard deviation can you attribute to this thing? Now, for those of you who don't know, as a very, very rough rule of thumb, each grade in the public school system is about 1 standard deviation up from the one before it. So think about these numbers as fractions of a year in public education. And he's primarily looking at K-12. Okay? He's not interested in tertiary education or adult education. So with those caveats, let's have a look. Shifting schools costs you 1/3 of a year. With nothing else going on, moving a kid out of their environment and sticking to another costs them about 1/3 of a year in their education. It's disruptive. Okay? Web-based learning, the effect is so small that it's just not worth worrying about. Teacher subject matter knowledge turns out to be relatively unimportant. And as a rule of thumb, you're looking for about a 0.4 to get excited. Anything below a 0.4, yeah, I'm not going to worry about it. Teacher subject matter knowledge, you don't have to be an expert to teach. And in fact, what we have found with software carpentry is it's better if you're not, because experts don't remember what novices don't know. What about class size? People get really excited about this. It turns out there's a weak effect. When there are problems that are attributed to class size, they're usually due to something else. Take a look at the bottom one there. The strongest effect found, if you want to improve learning, is to get rid of the disruptive students. And much of the misattribution to class size is simply a reflection of the fact that a larger class is more likely to have disruptive students in it. If you can control for that, the class size effect goes away. That's interesting. Motivation. Okay? Motivated kids learn faster. Okay? What about concept mapping? It's a simple note-taking technique where you draw pictures of the ideas and the relationships. Okay? What about peer tutoring, getting the kids to teach each other? How many of you pair program? Okay, how many of you pair learned, even informally? Okay, that buys you half a year. That's a pretty cool thing. Formative evaluation for teachers. Let me give you a scary statistic. In the Canadian and American public education systems, the average teacher has another teacher in his or her classroom 4 hours a year. In the Finnish school system, the average teacher has another teacher in his or her classroom 3 hours a week. How many of you play a musical instrument? How much do you learn from having another musician listen and give you feedback? How many of you do a sport? Even if they're no better than you, getting the feedback, getting that other pair of eyes. How many of you get code reviews? The rest of you, please don't write code for me, okay? It's a normal practice in some school systems. It isn't in English language school systems. Look at the effect size, right? It's one of the top 5. How can teachers improve if they're not getting feedback on their teaching? There is a commercial site now called beasmartercookie.com. Teachers can post videos of themselves teaching to get feedback from other teachers. This is brilliant. This is absolutely brilliant. It's like YouTube, where people are posting videos of themselves playing guitar to get feedback on their playing, not on how good the song is, but on how well they're doing the keyboard and the fretwork. Okay? This is what the internet is for. So let's have a look at some other things. There are, broadly speaking, and I am going to generalize, my father taught me never hesitate to sacrifice truth for clarity, so I'm about to do that. Basically 3 mental stages with very clear divides between them. Novices do not know what they don't know. They do not have a mental map of the terrain. They don't know what the key concepts are, what the relationships are. So if you give them lots of knowledge, you are actually pushing them further back. Because what they're going to do is take those facts and put them into the boxes that they've got. But those are the wrong boxes. How many of you have ever TA'd a programming class? You've been the one doing the help desk. Okay, you know the people coming in and asking the questions, and the questions just don't make sense? That's why. They've taken the knowledge and they've tried to fit it into their existing model of the world, and that model is wrong, but they don't know that. It's the only one they've got. So the most important thing with novices is not to give them information. It's to give them a correct conceptual model. In our half-day introduction to Unix, we teach them exactly 15 Unix commands in 3 hours. But we teach them the pipe and filter model. We teach them history. We teach them how to write a for loop in the shell. We teach them how to save things in a shell script. We teach them the file and directory structure. So now they've got a map of the terrain. They know where the pieces are and how they're supposed to fit together, and then they can fill it in with knowledge faster than I can talk. And as you're discovering, I can talk pretty fast. Second stage is competent. Competent practitioners can do normal tasks normally. That's where most people stop. How many of you drive a car? Okay, you're probably a normal driver, right? I mean, helicopter gunship comes swooping in, bada, you don't know what to do. Not a normal situation, right? Happens in the movies all the time, less common, oh, sorry. Happens less often in Canada, right? Some of you are up from the States, drone capital of the world. Okay, competent practitioners are the middle of that curve. What distinguishes experts from competent practitioners? It is not how much knowledge they have.
Experience?
No. But how is that reflected? What does experience turn into? Because you can do things over and over. What differentiates the expert is the density of connections and relationships between the facts that they know. Think about it in terms of a graph. If your graph is sparsely connected, to go from the idea you've got to the idea you need to solve the problem might be 5 hops. But for Naomi, who's got a much more densely connected graph, it might only be 1 or 2. And this is why experts are usually bad at teaching novices. Because for the expert, idea A and idea L are adjacent. There's a link. For the competent practitioner, it's A to C to F to L. And for the novice, it's A to B over to Z to Q to Y, back to C to D. They can't see the jump. They don't have that link. Okay? All of your teaching has to be based around this. You have to know which group you're talking to. The most important thing to get from competent to expert is self-reflection. As far as we know, you do not become an expert without reflecting on your own practice. Again, how many of you do code reviews? Okay, I do not believe you can become an expert programmer without reviewing your own code, any more than you can become an expert musician without learning to hear yourself. So if you want to make that transition, what you have to do is teach competent people how to look at each other's work, how to read and critique somebody else's movie review, how to tell somebody that their shoulders are thrashing when they're swimming, whatever it is, so that they can then apply that technique to themselves, close the feedback loop, and become an expert. Okay, everything I have just told you is backed up by hundreds and hundreds of studies. There's evidence behind it. Let's work through the others more quickly. How many of you know about peer instruction? Peer instruction is a teaching technique which provably produces better results in less time. Here's how we do it. Okay? Thing number one, I ask you a multiple choice question and you all have to vote. You've got, A, B, C, D, or colored cards or clickers. Okay, so you've all committed to an answer. Step number two, you talk to your neighbors, little groups of 3 and 4, trying to persuade them that you're right. Step number 3, you have to vote again. Step number 4, I tell you what the right answer is. And now there's step number 5. You get to talk to your neighbors again. If you interrupt this process after each stage, you discover that almost all of the learning happens in step number 5. Why? Because in the discussion with you 3, you realized why he believes the wrong answer. So in the second round of discussion, you can correct his misconception. It gives you the power of one-to-one tutoring in a scalable fashion. Look for Eric Mazur's work. We have 20 years of evidence to back this up. Beth Simon's work at UC San Diego has replicated those studies with several hundred students over the course of 5 years. None of the existing MOOC platforms directly support peer instruction. And most of you don't use it in your classrooms when you teach because you've never seen it yourself. Okay, this is kind of cool. I've got 10 minutes left. I have to accelerate. Multimedia channel conflict, media first instruction, stereotype threat, 7 plus or minus 2. Okay, here's the most important thing. I will come back if there are questions. Train your trainers. Okay, I now run a class to teach people how to teach programming. The next one starts in June. It's online. Mail me. This is the one thing I really want to shout about. Not only do people learn how to teach, they learn how their colleagues are going to be approaching the problem. It doesn't matter what your playbook is, it matters that everybody's on the same page. Right? And yes, there is a great deal you can learn, and it does improve things. You can go there, teaching.softwarecarpentry.org, or you can go there. We are running a class on Monday. We're going to try to squeeze a few key ideas down into one day. There are still 6 seats open. If you're interested, I will put the URL up again, but I have to speed up. Here's lesson number 6. Python 3 didn't matter. Okay, I've been teaching for 16 years. I have never met anyone who switched to Python because of anything in Python 3. It did not bring us a single new user. What we could have done that would have made a tremendous difference to my teaching, other than fixing the installation problems, which they're working on, we should have fixed the standard library. Watching novices try to find things in the standard library. Is this OS or os.path? Or maybe it's shoutil, or maybe it's, I don't know, Fred, right? String IO versus C-string IO, and the list goes on and on. Most importantly, we should have done some usability testing. Andreas Stefik published a paper in 2011, and I love this work. Okay? Sorry about the crappy formatting. There's the URL. I'll post it up. What he did was compare how readable programs are to novices who've had brief instruction in 3 programming languages: Perl, Quorum, which is one that they're designing, and one with a randomly generated syntax. People given Perl performed just as badly as people given a language with a randomly generated syntax. And the internet responded as it always does. People went to the trouble of looking up his students' names in order to send them hate mail. And one of them dropped out of the program as a result. You can guess her gender. Okay, if this is how the internet responds to me doing research, I'm out of here. Okay? What's interesting in those comments is the people who are saying, your results aren't statistically significant. To which his response is, yes, they are. Here's my data. Here's my statistical analysis. P is less than 0.05. It's statistically significant. What people really mean is, I don't like your answer, therefore you must be wrong. So he went back and he redid that study, but he turned up the volume. Stefik and Siebert. You can find copies of that if you Google for it. The idiots at the ACM put everything behind paywalls. You can't read this, so let me give you the high points. Step number 1 is go through with lists of words and terms and symbols to ask novices, which ones of these do you think mean the following things? Interesting discovery, in a list of 20 words, the ones that place bottom for meaning do this multiple times are for and while. They are the least likely to novices to mean repeat things, because for means do it for somebody else and while means something to do with time. Nobody guesses that that means repeat. If you change it so that the key word is repeat, people find the concept easier to learn because they don't have to unlearn the old meaning. But that's just step 1. Let's do step 2. Once people have had a bit of instruction in the language, let's see the accuracy with which they can identify constructs in Ruby, Java, Perl, Python, Randomo, that's the random one, and Quorum. Note that every feature in Quorum has been A/B tested before it's put into the language. Languages with C-style syntax do not outperform randomly generated languages. Perl and Java both sucked as much as Randomo. Ruby and Python outperformed, and Quorum outperformed both. Gosh, isn't that interesting? How many of you build websites? How many of you do usability testing on your websites? How many of you do usability testing on your language? How many of you have ever seen a usability test attached to a PEP proposing a change in the Python language? Why the hell not? We can do it and build a more usable language. Okay, last thing, because it's time for me to wrap up. Would you like me to buy you and the person of your choice dinner? Convince me that you have an answer to the following question. Why the hell don't we write lessons the way we write software and encyclopedias? How many of you contribute to an open source project? Okay, so we know from hundreds of projects that you can have thousands of people over the course of a decade contribute small bits and pieces to improve something. How many of you have ever edited a Wikipedia page? Okay, so we know that we can have thousands of people over the course of a decade or more collaboratively create something which is complex and readable. Read the Wikipedia article on the causes of the American Revolution. It's beautiful prose. It explains complex things, and it's had several hundred contributors. How many people have ever seen a lesson or lesson plan that it had more than 3 authors? More than 10, right? More than 50. Yeah, Paul Olivier is an outlier here. I'll be talking to you later, sir. Why don't we do this? Now, I could understand if this was 1995 and nobody had thought of it, but we've had Wikipedia as an example for what, a decade and a half? You can't say it's because the technology is hard. I mean, teachers may not be programmers, but they can edit Wikipedia articles. You can't say that it's because there's no benefit to the teachers themselves. I really like being able to take somebody else's slide deck and tweak it and use other people's exercises. You can't say that it's because people are afraid of putting themselves out there on stage. This is the internet, right? It was invented so that people with psychological disorders could get jobs, right? And get respect from their community. Like every single thing, every single reason you can think of why teachers and other educators don't collaborate on the construction of teaching materials the way we collaborate on code, the way other people collaborate on Wikipedia, every single one of those applies equally well to these 2 cases. And yet, despite dozens of attempts in different countries and by different communities, I don't know of anything like Wikipedia for lesson materials. Things like CNX are upload your slide deck so other people can download it. There is no merge. There is no culture of contribution. If you want to change education, like really change education, fix that, right? That would be cool. So this is me, and there's apparently some OS X updates available, so I should just ignore that. Thank you, Apple. Okay, so I'm at softwarecarpentry.org. All of our lessons are in a GitHub repo, and we get people talking, okay? There's another project called the Architecture of Open Source Applications, and we are currently looking for technical reviewers for things called 500 lines or less, so let me wrap up. Please ask me about the scraping sprint. Please ask me about the turtle sprint. Please ask me about NBDiff. Please ask me about 500 lines. Thank you very much.
Okay, thank you. We actually have even a minute or two more for questions, so we have a mic back here. Anybody who wants to ask questions, maybe about why there is no Wikipedia for lesson plans, any of that, please go back to that microphone and we'll take your questions.
And also, scrape, burp, burp, burp. I should have put those all in one slide. Sorry about that. Hi, how can I make your life better?
Hi, Greg. You already have, but
Do you know how you can make my life better? The whole samurai hair thing? It's
Yeah.
really kind of freaky. Go ahead.
I think the first time I asked you a question, you poked one at my glasses, so this is par for the course. So I was wondering if group signups could be used as a mechanism for addressing the gender parity issue with regards to conferences. So I proposed this for SciPy, but for various financial reasons, it wasn't able to happen. And could we apply that there? Could it happen at PyCon?
Do the experiment and report back. Quite seriously.
Yep.
We can make arguments both ways, but more and more. Hands up if
Okay.
you know what a Scottish verdict is. Okay, juries in Scotland are unique in the English-speaking world in that they can return one of three verdicts: innocent, guilty, or not proven. Increasingly, I think that we should adopt Scottish verdicts in more cases than we do. We don't have evidence. It's a plausible argument. Try it and tell us if it works.
Okay.
Right? Let's iterate. Okay, who's up next?
Hi, thank you for a great talk. I teach programming to teenagers, have done so for about a year with a nonprofit in the Bay Area. We recently tried adopting pair programming. One of the main challenges I find with teenagers is, so none of them know each other before the course. And teenagers are very rambunctious. They're very hard to manage in pairs. Sometimes one will get stuff at the speed of light, the other one will struggle. You try to switch pairs around, but then you just kind of delay the problem with other groups. It's kind of hell to manage with teenagers.
Okay, and you've already identified your problem. They don't know each other coming into the room.
Yes.
Okay, fix that, and your other problem will go away.
Interesting. Thank you.
Okay, cheers. Paul Olivier.
So I disagree with the statement that's now on the screen. So if you go to metacademy.org, that's a website that's powered by GitHub on the back end, so anyone can contribute. And that shows lesson plans in a graphical way, and you can plan your course.
How many people here have seen mathacademy.org or knew it existed?
Metacademy.
Sorry?
Meta.
Metacademy. My
Yeah, right.
apologies.
So that's my first attempt at getting a free dinner.
Okay.
You don't have to...
No. You have to explain to me why this isn't normal. Right?
Well,
You've shown that you can do it with heroic effort, and you have put in heroic effort. And for those who don't know Paul Olivier, he deserves a round of applause as well. But
No.
you have to convince me you know why this is not normal.
It's just starting. It's just people figuring out that's the right way to do it.
Wow.
Anyway, this is just attempt number one. You can evaluate, we can decide.
Yep.
Attempt number two will come when this thing that is filmed now will be put up on YouTube, then later on someone builds a course on Coursera that tries to get lots of people to use tools like that. So at that stage, out of hundreds of thousands of people, maybe 100, 200, 300 teachers actually start using those tools.
Okay, and I first heard this is just around the corner in 1996.
Right.
Okay? And so I don't believe it's just around the corner. I believe there is a force acting in the other direction that I don't understand. My model of the world predicts that this should be the normal thing. It is not the normal thing. So I'm wrong about something. There's something I don't understand. Okay? Thank you, Paul Olivier.
And I'm just convinced we have the tools now to make it
Oh, we
happen
had the
quicker.
tools. We've had the
So-
tools as long as there's been Wikipedia.
Stay tuned for attempt number two.
Okay, please, sir.
So I just went to an open space just before this conference on education, and I am amazed that you brought up the same point that I brought up concerning translations, actually, because I agree that we don't have any, as programmers, it's easy to collaborate, but as educators for content, we don't have any platform that makes it easy.
Yes, we do. It's called Wikipedia. There
No,
have
but
been-
Wikipedia is for content, it's not for education.
Coursepedia, Learnopedia, the Learning Commons, there have been dozens of attempts to take exactly that software and plop it up and get teachers to do this, and they have all failed. At least all the ones in the English-speaking world. I cannot speak for other communities. I would love to know if this has worked in Brazil or South Africa or China or someplace else that I can't see into because of my language disability.
Well, I'd say that hasn't worked at all because we don't have any platform to translate, actually. And we don't have any good platform to translate content, education content. We don't have any.
Okay, that's a possibility. Technical issues, go.
So I'm one of the Python core devs, and one of the things we have is for all of this stuff, if we want to take any of this feedback, we have to go hunting for it in academic papers, all somewhere else. Come talk to us.
Yep.
Our mailing lists are open.
Oh.
Yes, we can be assholes sometimes, but
Sometimes.
yes, sometimes.
Dude, I'm on the PSF list.
Yeah. So, PSF is not Python dev, and PSF's getting better too.
Yeah.
But it's the thing of okay, there's wonderful stuff we should be doing, but we have no money, we have no resources,
But
we
teachers
need people
do.
coming to us.
But teachers do. So
So-
why aren't teachers, why aren't high school math teachers who have rock solid curriculum and a fixed point problem doing this?
Yeah.
They all teach out of the same textbook. So why aren't they doing this? Right? It's not just about programmers. Why are social studies teachers not collaborative building lesson plans? Because they're used to using other people's material. The idea that you have to build your own material, most K-12 teachers don't. They take standard material and improvise on top of that in the way that jazz musicians improvise on top of a score. So the idea that we have to build all of this ourselves, right? Or the idea that it's a technical challenge, I'm still not buying dinner. But yeah, thank you very much.
It's incentives. I'd back it being incentives.
Okay, and the
I'd like to
incentive-
take a crack
so-
at the dinner.
Okay, so all of the arguments saying they don't have incentives apply equally well to open source. And I was there in the 80s and 90s when people were saying open source will never take off because why would anybody give away software?
They have disincentives to fear the internet.
Okay, please.
I actually can't put the mic straight. But I have a question about this. Isn't it kind of contradictory? Like, because I've been seeing this a lot. Like, go have programmers write curriculum.
Right.
Instead, you wrote terrible curriculum.
Absolutely.
So the problem, like, we're going to go public with the development. How do we actually make sure that people who know how to teach
We point social studies teachers in Ontario at an instance of the Wikimedia software and say start developing there. I'm not looking at this as a programmer's or programming problem, right? It is routine now for teachers to not just use but edit Wikipedia articles in the process of building course material. Take a look at who the contributors are. So why are they not taking exactly that and doing it for lessons? It's not about programmers. Yeah. And again, we can find point solutions. Why is it not normal? Okay. Okay. And that's the challenge, is why has this not already become just the normal way of doing things? Okay, I'm sorry. She's got a couple of examples like CS Unplugged, where there are people collaborating on curriculum. The open source textbook that Dave Humphrey and others contributed to. There are a few point solutions. There are a few instances. There is nothing that has been widely used or has spread. Right? It's as if the only open source software in the world was GNU Emacs. Okay, now I'm depressed. Oh, that was a bad vision. Okay, the argument now is that teaching is still localized. I'm sorry, have you looked at the Common Core? Right? Have you looked at centrally mandated teaching? Okay, I'm sorry, we're going to have to go to the next one, but argue with me afterwards. I'd love to buy you dinner. That came out so wrong. Go ahead, please.
Please use
Microphone.
Please use the mic.
Yep.
Okay, so I'm not a teacher, but I'm a student, and I can tell something from a different perspective. Because at my school, when I was at high school, my teacher, maths teacher, organized something like math camp, and it was like done by students, by us, for us. It was like we were totally into it. I mean, we were taking part into Maths Olympiad. It was also like in computer science, but we students just found out about the topics we want to learn. There was a group of people who, I mean, those students. It was not at school. It was very important that we went somewhere with our teacher. It was like 3 schools from my country, and it was like from the very morning till the very evening, and
Okay. We're running short on time, so is there a question or a proposal?
No, it's like why? Well, it's not very common use. Well,
Right.
not around the world.
The book that has changed my mind about teaching the most is Seeing Like a State. Hands up if you've read this. Hands up if you work in a large dysfunctional organization, and those two words are the same. Okay, this is why. Over and over again, large organizations prefer the illusion of central control over productivity or success. Think about collectivized farming under Stalin. It produced 1/20th as much food, but it gave Moscow the illusion that everybody was doing things the way they wanted. Think about software development at IBM. I lived through that. It was indistinguishable from collectivized farming. So, this is a really good book, and there are case after case after case. And what we see with centralized curriculum is that we have to squeeze out the individuality, which actually leads to better performance. So I understand that as a possible argument. What I don't understand is why nobody's managed to break past that. And I'm out of time, aren't I? Okay, ladies and gentlemen, thank you very much. I apologize
Thank
for
you very
running
much.
over.